If there's one star that bends the rules of physics without collapsing into oblivion, it's a tiny sphere spinning somewhere in the darkness between the constellations Hydra and Sextans. Astronomers call it Pulsar J09520607, but behind that cold name hides something far stranger, a dead star, reborn as a cosmic engine. It's the fastest spinning neutron star ever found, a Black Widow Pulsar feeding off its partner like a vampire. And it might just be the heaviest neutron star in the universe. Imagine something no bigger than a city, yet heavier than 2 suns. A teaspoon of its matter would outweigh Mount Everest. It spins nearly 700 times every second, faster than a kitchen blender's blades, firing out beams of radiation that sweep across the cosmos like lighthouse beams. Every flash we detect from Earth is one heartbeat of this impossible survivor. But to understand how this monster came to be, we have to step back to the death of a normal star. When a star about 8 times the size of our sun burns through its fuel, it can no longer hold up its own weight. Gravity wins. The star's core collapses. Electrons and protons fuse into neutrons, and what's left behind is a sphere barely 20 kilometers across, a neutron star. It's so dense that atoms themselves cannot exist, only pure nuclear matter, crushed together by unimaginable pressure. Now, most neutron stars quietly spin in the dark, but some, like J09520607, turn into something even stranger, a pulsar. These are neutron stars that rotate so rapidly and have such intense magnetic fields that they shoot out jets of energy from their poles. As the star spins, those jets sweep through space, and if one happens to pass across Earth, we see a pulse, a cosmic tick, repeating with perfect precision. It's like the universe's most extreme clock, but J09520607 isn't just fast. It's a Black Widow Pulsar, part of a deadly binary system. Long ago, it had a companion star, a normal neighbor that wandered too close. Over millions of years, the pulsar's radiation and gravity began to strip matter from that companion, stealing its mass bit by bit. Astronomers nicknamed it the Black Widow because it literally feeds on its mate, leaving behind only a faint ghost of what used to be a star. This constant feeding spun the pulsar faster and faster, like an ice skater pulling in their arms. Eventually, it became the fastest known spinner in the entire Milky Way, rotating nearly 700 revolutions each second. But its speed wasn't the only shock. Measurements revealed its mass was nearly 2.3 to 5 times that of the Sun. That's terrifyingly close to the theoretical limit where a neutron star should no longer exist at all. At that point, gravity should crush it into a black hole, yet it hasn't. It sits right at the razor's edge between existence and collapse, holding itself together through sheer spin and magnetic pressure. If it were even a little heavier, it would vanish behind an event horizon. Scientists studying it realized they might be looking at the final possible form of matter before nature gives up and lets gravity take over completely. And the more they studied it, the more impossible it seemed. Its rotation is so stable that it loses less than a fraction of a second over millions of years. Its beams of radiation are so focused that even from thousands of light years away, Earth can still detect its pulses. Some astronomers call it the cosmic heartbeat. Others see it as a warning proof that the universe can bend the rules of physics without breaking them, at least for a while. But J09520607 isn't alone. It belongs to an entire family of extreme objects that test the boundaries of existence. Some spin slower, some faster, some collapse under their own weight. And among them are stars that make even this Black Widow Pulsar look tame. Because out there, scattered through the Milky Way, are stars that don't just spin fast or weigh too much. They are magnetic monsters whose power could tear atoms apart. And what happens inside those is even harder to believe. But that's where the story gets darker and far stranger. Because not all neutron stars simply spin or feed. Some are born with magnetic fields so powerful they can twist space and tear apart matter itself. They are called Magnetars, and their story takes us into the most violent realms the cosmos has ever known. If neutron stars are the universe's strangest survivors, then Magnetars are its most violent children. These are neutron stars born under extraordinary conditions. Their magnetic fields are so unimaginably intense that they stretch the limits of physics itself. A magnetar's magnetic field is 1,000 trillion times stronger than Earth's, powerful enough to distort atoms, alter the vacuum of space, and even interfere with quantum behavior itself. If one of these monsters were somehow placed halfway between Earth and the Moon, its magnetic field would be strong enough to wipe every hard drive, erase every digital record, and scramble every electron on our planet. That's how powerful they are. Up close, the laws of physics themselves begin to twist. The magnetism is so fierce that it reshapes the very structure of matter, stretching atoms into bizarre, elongated filaments like cosmic spaghetti. The crust of the star, a shell harder than any metal known to humankind, trembles under that immense pressure. And sometimes, it breaks. When that happens, a starquake rips through the surface. The magnetic field reconnects violently, releasing a burst of energy so powerful that it can outshine entire galaxies for a brief instant. In that single heartbeat, a magnetar can unleash more energy than our sun emits in 100,000 years. These cataclysms are so intense that their radiation can travel across intergalactic space, occasionally detected by satellites orbiting Earth as mysterious gamma-ray flares the aftershocks of a star screaming in magnetic agony. There are only a few dozen magnetars known across the cosmos, but each one is a ticking time bomb. Their magnetic storms ripple through the universe, bending light itself, twisting space-time, and pushing the limits of what even modern physics can describe. They remind us that the universe isn't a silent void even in death. Stars roar, tremble, and shout their final defiance into the darkness. But if that sounds extreme, it's only the beginning, because there's something even more catastrophic that can happen. When two neutron stars, two of these cosmic titans, spiral into one another. For millions of years, they dance a slow, deadly waltz, their gravity tugging and twisting space itself. Every orbit brings them closer. Every spin radiates away energy in the form of gravitational waves, literal ripples in space-time. And then, finally, they collide. That moment isn't just violent, it's creative. In 2017, humanity witnessed such an event for the first time. GW170817. Detected by LIGO and Virgo, this wasn't just a discovery, it was a revelation. For the first time, we saw and heard the universe create matter. When those two neutron stars slammed together, the collision forged elements that had never existed before. Gold, platinum, uranium. The heavy metals of the universe were born in that single cosmic flash. In just a few seconds, that explosion produced more gold than all the stars in the Milky Way combined could ever make in their entire lifetimes. The light that followed, a kilonova, was so bright it briefly rivaled 1 billion suns before fading into silence, leaving behind either an even heavier neutron star or a brand new black hole. And that's the quiet miracle of it all. The gold in your jewelry, the platinum in your phone, even the atoms in your blood were once part of a dying star. Every element heavier than iron, the things that make life, technology, and civilization possible, was forged in an instant of destruction. The universe creates through chaos. Even death has purpose. But how far can nature push matter before it finally gives up? That question brings us back to our impossible star Pulsar J09520607, the record-breaking Black Widow Pulsar. Its mass is a paradox, nearly 2.35 times the mass of the Sun, compressed into a sphere no wider than a small city. That puts it right on the edge of the Tolman-Oppenheimer-Volkoff limit, the theoretical boundary beyond which no neutron star can survive. Cross that line, and even neutrons, the densest stable particles known, collapse under their own gravity. Space folds in, time stretches, and a black hole is born. But J9520607 isn't collapsing, not yet. It lives on that razor's edge, spinning so fast that centrifugal force and magnetic pressure hold back the inevitable. It's nature's final experiment before surrendering to gravity's absolute rule. Every rotation of that star is a fight for existence, a cosmic balancing act between stability and annihilation. And yet, it's not the only mystery. Beyond neutron stars, beyond magnetars, scientists have proposed even greater beasts. Quasi-stars, ancient titans from the dawn of the universe. Imagine a star so large it could swallow our entire solar system, powered not by fusion, but by a black hole burning at its core. These monsters could have lived briefly in the early universe, collapsing to form the first supermassive black holes, the same ones we now see anchoring galaxies, including our own Milky Way. If those quasi-stars truly existed, then every galaxy, every planet, and every living thing owes its existence to them. The light in our skies and the life in our veins may trace back to their brief, incandescent reign. So, when we look at neutron stars, magnetars, or black widows like Pulsar J0952 we aren't just studying dead suns. We're peering into the universe's laboratory, where creation and destruction are the same force, wearing different faces. These are the experiments through which reality tests its limits. But one day, even the Black Widow Pulsar will slow down. Its spin will falter, its beams will dim, and gravity, patient, relentless, will finally collect its due. It will collapse into a black hole, silent and invisible, but its legacy won't die. The matter it stole, the energy it released, the elements it helped forge, they will drift across galaxies, seeding new worlds, new stars, and maybe new life. Every rotation of that pulsar is a heartbeat of resistance, a whisper that says, even at the edge of collapse, the universe endures. It transforms, it evolves, it creates beauty out of destruction. Maybe that's the secret written in the stars, that death and birth, creation and collapse aren't opposites at all. They're partners in an eternal cosmic rhythm, endlessly trading places. The same explosion that destroyed a star billions of years ago might now shine as the gold on your wrist or the air in your lungs. So the next time you look up at the night sky, remember, somewhere out there, in the cold between constellations, a city-sized star, heavier than 2 suns, is still spinning, defying the impossible. Holding together against the pull of oblivion, it's proof that even at the edge of death, the universe never stops shining. Every collapse is a beginning. Every ending, a new creation. And maybe that's what the cosmos has been trying to tell us all along.